This lesson starts a unit on inequalities. So we spent a lot of time talking about equations, and now we're going to get into inequalities. This is actually a pretty hefty unit here, and there's a couple of things to explain, or like hefty lesson that I really want to make sure that I cover in detail. And it's going to be quite a few example problems to do. So for inequalities in one variable, first let's talk about what an inequality is. There are four really like what are called simple inequalities, and you should have seen them before. They are this, and then this, and this. Now, where a lot of students tend to get confused is they start to think of this as being different symbols. This is one symbol, and it just orients two different ways. And which way you read it, whether you read this as greater than or less than, has to do with the fact that we read from left to right. Okay, so if you have, and hopefully you did this in elementary school or something, you had, these two numbers and you asked to put something in between them. Okay, the way you decide how to put it is you're reading from left to right. And so you go, 2 is less than 3. And a lot of times teachers will say the alligator is always hungry, so he eats the bigger thing. Or like L, like it looks like a sideways L. You can kind of see an L there. It's like for less than. But just remember, like, it has to do with the direction you're reading. So if you read from left to right, you're going to read 2 is less than 3. If you're reading it the other way, now you're coming at it from the direction like where the mouth is opening. So you would read it as greater than. 3 is greater than 2. And that works if you have like a variable, okay? So X is less than, and then this bar there is actually like the bottom part of an equal sign. So instead of, you got the equal sign, instead of having like the top and bottom bar, the top bar gets turned into the inequality, but the bottom bar still stays there. So we have there less than or equal to, and then you could read it the other way. 4 is greater than or equal to X. Yep. Okay, so just letting the feline help. And so it's really just one symbol. And most of the time we read from left to right because that's the direction of the number line and that's the direction of the English language. And so, we just read from left to right. Now, when you're graphing an inequality in one variable, you might have something like this. X is less than 2. And so you look at your number line and you look at the number 2 and you're thinking, okay, well, where are the numbers that are less than 2? Well, they are to the left. That's the direction we go. And what we do in math, and I do this with my Algebra 2 kids, I say this is a key concept. This is really a key idea here, okay? We shade or we color or we plot, like you can use whatever word you want there, the points that make the equation or inequality, in this case, true. And that's really all we've ever done when we've graphed lines. Like you're graphing all the points that if you plug them into that equation are going to make that equation true. And if you need to go back and rewatch that first video from Unit 4 on graphing a line, like I think that's where I spent a lot of time talking about it. So where are the points that make this true? Well, those are the points that are less than 2. So that would be points like over here. 1 is less than 2, 0, -1, and so forth. Here's the clincher, okay? And so that's an infinite number of points. So we just kind of color it in because we could do this and just plot like an infinite number of points, but we just color it in. As you get close to the 2, okay, you have all these points. You get 1, 1.5, 1.6, 1.7, 1.8, 1.9, 1.99, 1.999, 1.99999999999 is still less than 2. But the moment you get to 2, now it's not less than 2. So what we need to do is we need to mark the 2. We need to mark that boundary. But we don't want to include the 2, which means we don't want to shade the 2 because the 2 is not something that makes it true. And the way we do that is with what's called an open circle or an open dot. Okay? And it marks the boundary, but because we leave it unshaded, what we're doing is we're saying that actually doesn't work. All it is the boundary. Now you can change that and make it less than or equal to 2. Okay, and now it's everything less than 2, so it's all these infinite number of points over here that we don't want to do all these dots, so we just kind of shade it in. And now the 2 is included, and so remember that we shade the points that make the equation or inequality true, and so now we would shade that saying, okay, the 2 is the boundary, but the 2 also works. Okay, so here's the deal with solving linear inequalities. It's really great news. They solve exactly the same way that linear equations solve. Everything distributes, your inverse operations, combining like terms. So everything is the same with one little caveat. And that has to do with if you multiply or you divide by a negative. Okay. And I have tried to illustrate and explain this. It's just one of those things that at some level you just have to remember that it works. But I do want it to make some kind of sense to you as to why it works. And so I am going to try to explain that. Might make this lesson a little bit longer. But here we go. So let's take a look at this. We have p plus 5 is... And then you do want to train yourself to read that correctly. So we're reading from left to right. And so we're encountering the open end first. The alligator's hungry and it eats the bigger thing. So p plus 5 is greater than or equal to 3. Now, if you were to picture this on like the little balance scale, normally for an equation, we draw it balanced. And we have this idea of you got to do the same thing to each side in order to keep it balanced. This is not an equation. This is an inequality. And whatever we have on the left weighs more than whatever we have on the right. All right, so you've got like p plus 5, and that weighs more than the 3. So I want to solve it for p, which means I have to subtract the 5 from the left-hand side. So I'm going to do minus 5. But kind of look at the balance scale here. If I take away 5 from the left side, and I don't touch the right side, what might happen is that it's going to tilt the other way. Like if I take some of that weight off, I actually don't know, because we don't know the value of p. I actually don't know if it's still going to be tilted the same way. And so in order to make sure that it stays tilted the same way, just like with an equation, we end up having to do the same thing to both sides. Not to keep it balanced, but to make sure it stays unbalanced in the same way. And we don't want to accidentally change the which way it's tilting. So this ends up being p is greater than or equal to -2, and that is the end of that. You might be asked to graph it, okay? And the only number I make my students plot is whatever number is in question. Greater than means we're going to the right, and it's or equal to, which means that that endpoint is included, and we shade the points that are included, the points that make it true, which in this case -2 does. All right, let's look at another one. We're just going to really run through a lot of examples here. So make sure you can read it out loud correctly. Like you really want to train yourself. A lot of my students are very uncomfortable with the inequalities, how to read them, and making sure that they're understanding like which way this relationship goes. So look at the way it's oriented. Okay, we know it points to the smaller and eats the bigger. That's always true. And the way we're going to read it is from left to right. So we're going to hit the pointy end first, which means that 2y minus 5 is less than 7. Same symbol as was going on over here. So which way you read it, if you read it as greater than or less than, just is determined by which direction you're hitting it from. And since we're reading from left to right, here we're hitting the open alligator mouth first. So this is the bigger side. P plus 5 is greater than or equal to 3. 2y minus 5 is less than 7. And the same principles for solving it hold. So I would undo subtraction with addition. And then as we explained in the last problem, you need to do the same thing to both sides, because we don't want to accidentally get it tilted in the wrong direction. Like we're given like this is less than this other thing, so we need to make sure that it stays tilted the same way. And then we would undo multiplication with division. And so we end up with y is less than 6. Here's the 6. Where do we find our numbers that are less than? That would be to the left. And the 6 is not included. It's not or equal to 6. So the 6 is the boundary, because we can go up to like 5.99999999999. You get the idea, but not the 6. So we mark the 6 there. Now, there are some cases where you actually need to flip the inequality around. And this is what throws students off. Students will not flip the inequality when they're supposed to flip it, and they will flip it when they're not supposed to. So we really need to be clear on when do you flip it. And what I would like to get at a little bit is why do you flip it? Because if you understand the why, then you're a lot more likely to remember when you're supposed to do it. So I'm going to use a pretty straightforward example here. I'm going to say -2 is less than 6, which I think everybody would agree. Like if you look at the number line, you got -2, you've got 6, -2 is to the left of 6. Okay. Now, if I divide that by a +2, okay, then I end up with -1 is less than 3, which is still true. Okay, so no problem when you're dividing by a positive. Like that doesn't change the order. But watch what happens when we divide it by a negative. So I'm going to just like draw a line here. So we have -2 is less than 6. So we'll put that, I'm just recopying it. Okay, when I divide by a -2, observe what happens. So negative divided by a negative gives me a positive, and a positive divided by a negative gives me a negative. And now look at what those numbers are. Instead of getting -1 and +3, which is what I got when I divided by a positive, dividing by that negative has like flipped them around over to the other side. And so now I have a -3 and a +1. Just notice what happened there, because when it only happens when you multiply or divide by a negative, but it flips the sign of the numbers, and when it flips the sign of the numbers, it orients them the other way on the number line. And so in order to compensate for that, we actually need to turn the inequality symbol around so that we are getting a true statement. 1 is greater than -3. Now, I know that isn't what's called a proof. You will encounter the joy of proofs in geometry. That's not a proof, but you really could pick any two numbers. Like you could just keep like picking as many numbers as an example, like to convince yourself that this will always happen. That introduction of the negative in what you're dividing by changes how this is oriented, and it's going to flip the things around. So here's what you need to know. If you are multiplying or dividing by a negative, so it has nothing to do with the number that's being multiplied or being divided. It's the one that you're introducing into the problem, like to carry out an operation, okay? Flip the inequality. And like I said, at some level, you just need to memorize that. You just need to know that that's what you need to do. But hopefully now that I've illustrated this, the reasoning behind it is grounded in a little bit of a why you need to flip it, rather than just somebody telling you, oh, by the way, flip that inequality around for no apparent reason. Like the reason you're flipping it is because that negative is going to change the sign of everything involved in the problem. So let's see how that plays out in an actual problem. So suppose you have 5 minus x is greater than 4. And again, make sure you're reading that correctly because you're reading it from left to right. So you're encountering that opening, like the hungry alligator first. So 5 minus x has to be the bigger, greater than 4. I want to get x by itself. So I subtract 5 from both sides. 5 minus 5 is 0, leaving us with negative x is greater than negative 1. There's no flip there. It's only if you're multiplying or dividing, and only if you're multiplying or dividing by a negative. Well, right here, this is a negative 1. I was taught to multiply both sides by negative 1, but usually when I teach this, I teach it with dividing both sides by negative 1. And that right there is the trigger that's going to make it flip, because we're going to end up turning the sign around on this. So that you guys can't see my hand gestures. I'm like twisting my right hand like I'm turning something. So we have a negative divided by a negative. It's going to turn that into a positive. It's going to flip everything around. So x is less than 1. And again, at some level, you just got to remember when to do it, but slow yourself down. And what I did over here, you can do that on your own. You can do that in the middle of a test. I mean, that's a little process that you can do out in the margins to just kind of remember what that is. And then if you're graphing it, plot the 1. X is less than 1, so that would be to the left, and the 1 is not included, so we use an open circle. One more example problem. And this is if you have the variable on both sides. So we have 2x minus 4 is, I won't read it out loud. I'm going to give you a second to think about it. So take a moment, just take a moment in your head and read that out loud in your head. I guess that's not out loud. Do it out loud, as long as you're not in the middle of a class or something or on the subway. Okay, so you should have read that as 2x minus 4 is less than or equal to 4x minus 1. Okay, that's how you read it. And again, everything works the same. So distribution works the same, combining like terms, inverse operations, and so does isolating the variable. There's actually 2 ways that you can do this. And I'll work it out both ways. It's going to make the video a tiny bit long, but I think I'm okay with that. I would probably do it this way. I would probably subtract 2x from both sides, and 2x minus 2x is 0, giving me negative 4 is less than or equal to 2x minus 1, and then I would add 1, and that would give me negative 3 is less than or equal to 2x, and then I would divide both sides by 2, and I would get negative 3 halves is less than or equal to x. Okay, now when I look at this, I'm like, okay, well, I get that negative 3 halves is less than or equal to x, but usually you are expected to put the variable on the left. So remember that you can read this, like you can read it, you go back to the very beginning of this lesson, you can read it in either direction. So negative 3 halves is less than or equal to x, but if you're reading it this way, you're going to encounter the hungry alligator first. So you would say x is greater than or equal to negative 3 halves, and I would just rewrite it like so. Just kind of turn it around. So x is greater than negative 3 halves. X is greater than negative 3 halves. And then for my graph, greater than or equal to, sorry about that. I'm just going to put the 3 halves. Greater than is to the right, and the negative 3 halves is included. Now, the other way you could do this, and so we'll just kind of work this another way, which a lot of people like, that's how I would do it, because flipping this doesn't bother me when I get to the end, but it does bother some people. So let's just kind of look at another way you could do it. 4x minus 1. Okay. So the other way you can do it is subtract the 4x from both sides. And what that does is it gets your variable on the left. Okay, so 2x minus 4x is negative 2x. And now we will add 4 to both sides. So we get negative 2x is less than or equal to 3. And then we'll divide by negative 2. But dividing by negative triggers the flip. And so we have x, and now we've got to flip the less than around to a greater than, 3 over negative 2. And just remember that the negative, the position of the negative in the fraction doesn't matter, and so you might move it up to the numerator, and you'll notice we get the same answer. Okay. You can do it either way. You can't get away with not flipping it. Like at some point, you're probably going to need to rewrite it so that it is more comfortable to read, but both ways work. So the good news about linear inequalities or inequalities in one variable is that everything that you've learned with equations still works for inequalities. I've said it on these videos, and my students are probably sick and tired of me saying it, but math is consistent. The rules are consistent. And so, what works for equations is going to work for inequalities. And then it's really up to a teacher to kind of introduce and explain like when something isn't what you expect it to be, so that you have a chance to think it over and practice with like that new idea, and hopefully explains why something is different and doesn't just like throw out a random fact. So as always, I'm going to put some practice problems up on the screen, and then pause the video and work them out, and then check your answers. Great. I have no idea why I wrote the word solve a million times there. Probably could have been more efficient with that, but my handwriting is terrible, so I will read through the problems out loud. So we have graph x is greater than -4, graph x is less than or equal to 9, and then solve each of the following. -3 plus x is less than 19. 6 minus 3x is less than or equal to 15. 17 is greater than or equal to 4x plus 8. 3x plus 5 is less than -7x plus minus 9. 2x plus 10 is greater than or equal to 7 times x plus 1. And then for the last one, solve it and graph the solution. -x plus 4 is less than -2 times x minus 8. As always, pause the video, work them out on your own, and then unpause to check your answers. Okay, I got a lot of fractions for answers for these, which is a little bit unnerving. It unnerves teachers too. So let's see if I catch any mistakes when I'm going over it. So for the first one, x is greater than -4. Again, remember to read that correctly. So greater than means you're going to be shading to the right, and you're not including the -4, so you should have an open circle there. Graph x is less than or equal to 9, so less than is going to shade to the left, and you are including the 9 because it's or equal to, so we shade in whatever's true, so you're going to have a closed circle or shaded circle at the 9. For number 3, we have -3 plus x equals or is less than 19. Add 3 to both sides. -3 plus 3 is 0, and then 19 plus 3 is 22, so we get x is less than 22. On number 4, subtract 6 from both sides. 6 minus 6 is 0. Don't forget that negative is still attached to the 3x. 15 minus 6 is 9. And then we divide by -3. And remember that that is going to trigger the flip of the inequality only when you're multiplying or dividing by negative. Most of the time it'll be dividing. And so x, and we got to turn that around, so it's x is greater than or equal to -3. As always, pause on whatever slide you need to pause to kind of catch up and fix your work or copy my work or do what you need to do before moving on. Next one, this is where the fractions started and then they never stopped. So 17 is greater than or equal to 4x plus 11. I went the route where I subtracted 11 from both sides. So 11 minus 11 is 0. 17 minus 11 is 6. And then divide both sides by 4. That does not trigger a flip. 6 over 4 simplifies to 3/2 because they're both divisible by 2. And now I've got like it solved for x, but it's not the way I want it. So remember how you read this? This is 3/2 is greater than or equal to x. If you're reading it the other way, it's going to go x is less than or equal to 3/2. And so I rewrote it as x is less than or equal to 3/2. In the more comfortable order. Number 5, I started by adding 7x to both sides. So 3x plus 7x is 10x, and then negative 7x plus 7x is 0, leaving me with a -9. Then I subtracted 5 from both sides, so I ended up with 10x is less than -14, and then divided both sides by 10. 14 over 10, those are both even. 14 divided by 2 is 7, and 10 divided by 2 is 5, and so I simplified that to 7/5. There is no flip there because you're not dividing by a negative, so x is less than -7/5. And then this one, so for this one I started by distributing, so I distributed the 7 through to get 7x plus 7. Then I subtracted 7x from both sides. So 2x minus 7x is -5x. Here they cancel out, leaving me with the 7. Then I subtracted 10 from both sides. So 7 minus 10 is negative 3. And now I have negative 5x is greater than or equal to negative 3. Divided both sides by negative 5. That triggers the flip right there. And so my greater than flips to a less than, and x is less than or equal to, and negative divided by negative gives you a positive, so positive 3/5. Didn't notice any mistakes in that, so I guess those are all fractions. Sorry about that. That probably unnerved you. All right, last one, distributed the negative 2. I did have a student ask me once, well, because you're multiplying by a negative, shouldn't you flip it? Only if you're doing it to both sides. That's the only time it messes with it, because it flips the sign of the whole side. Otherwise, it stays the same. So negative 2x plus 16 over here. Then I added 2x to both sides, so those cancel out, leaving me with 16. Negative x plus 2x is positive 1x. Then I subtracted 4 to get x is less than 12. And then on the graph, less than is to the left, and the 12 is not included, so we would use an open circle. So hopefully that went pretty well. That was a lot of material in one lesson, so rewatch it, do what you need to do, and I will see you in our next lesson on inequalities.